Now here we will discuss applications of definite integrals, volume by disks. If we consider a function which is a line, and we can say this is function a line, we can say y equals to r. This is the radius. We can treat, and starting point is 0, it is here, and end point h. So we can say 0h is our interval. Height of the cylinder h minus 0 is h. Now just imagine the line, this line y equals to r, let us say, being rotated about this axis, and when this line forms a complete revolution, a cylinder forms. So if we have the cross section, if we cut this cylinder into mid perpendicular to this x-axis, we see a circle, and we know that cylinder is the collection of circles. Therefore here we can just imagine this is the cross section and like circle, and we know that area of circle is pi r square, and integrate this area of circle, so we will obtain v 0 initial point to h dx. So we will obtain pi r square x. This is the volume of the cylinder. Now we will obtain volume formula for revolution by disk method. We are considering here disk method. So let us take a curve, any curve y equals to fx, which is treated as radius of this solid of revolution. Let us take starting point, this is E, and end point at x equals to b. While rotating it along x-axis like this one, a cylinder like figure will form. Then we can draw a figure here. This is y equals to fx. This is E point, end point is B. This curve y equals to fx is bounded in this way. And if we rotate this curve y equals to fx along x-axis, we obtain a figure like this way. So it will be the solid generated by this curve y equals to fx along x-axis. If we cut or take a cross section, we will obtain a circle type cross section. The cross section of the solid looks like a circle, and the radius we can say here y equals to fx, y equals to fx. So radius we can consider r equals to fx. The that will be produced volume that will be produced by rotating the curve around x-axis is Vx. Here it is A point, here it is B, like this way. Integrate between A and B. Pi fx square dx. Similarly, if we have x equals to fy curve, x equals to fy curve, and this is C, this is T, and if we rotate along y-axis, then we will obtain a curve like so. This will be, if we rotate this curve along y-axis, we will obtain a solid form like this way. And similarly, here we have a cross section like circle like cross section. So volume of this one, the solid forms will be Vy, volume around y axis revolving the curve x equals to fy, lower limit c to d, pi fy whole square dy. These are basic formula we will use in our practical and numerical problems solution. Here we have working rule for finding a solid of a revolution. Draw the curve on the coordinate plane and examine the axis of rotation. Examine the axis of rotation, whether it is x, so we can say with respect to x or y. We have to check. Next point, finding the limits of integration. And then finally apply the formula. If with respect to x, then we will apply volume around x axis equals to limit a to b pi fx whole square dx, as we have discussed. And if we rotate rotation along by axis, then volume around y equals to limit c to d pi fy square dy. We will apply this formula, and this working rule B will solve some numerical problems. The question is here, find the volume of this, find the volume of the solid that is obtained when the region under the curve over the interval one comma 4 is revolved about x-axis. Here we have solution steps. First step, we will draw the curve. So this is y-axis, this is x-axis. It is given that 1 and 4 interval. 1 is here, let us see 4 is here, and y equals to root x goes look like this one. We join this one. Then if we rotate this curve around x-axis, then we obtain the figure like this one. This rotation along x-axis. Curve is bounded in between this one. If we have here a cross section like a circle, so we have volume around x-axis equals to limit. Lower limit is 1. Here it is given directly 1 to 4 pi fx whole square dx. This is 1 to 4 pi under root x whole square dx. After simplification, we will obtain 15 pi upon 2 unit q. Thank you.